from 1010. Today's lesson is going to be pretty easy overall, but it is important that we remember it all. So let's start with exponential functions. Exponentials and logs, remember, are inverses of each other. Let's focus on what an exponential function looks like first, because that's half the unit. Half the unit's exponentials, half is logs. Exponential functions look like this. We have a red graph and a green graph. One is growth and one is decay. Growth will start out small and get exponentially larger over time, and exponential decay will start out large and get smaller over time. It's just algebra where these numbers come from, so let's do it. What makes it exponential is x is in the exponent. So this is considered base 2 raised to the x power. Since x is an exponent, it's exponential. Growth is when your base is larger than 1. So 2 would create growth. Let's get some values. Plug in -2, -1, 0, 1, and 2. You're writing this down. 2 to the -2, remember, is not a negative number. Remember, negative exponents do not calculate to be negative numbers. They calculate to be decimals. So that's 1 over 2 to the +2, right, everyone? Negative exponents get calculated by flipping them over a fraction, correct? Yes. Okay, so then that would be 1/4, which is 0.25. All right, 2 to the -1 is not a negative number. It's a decimal. What decimal? Well, let's do it. That's 1 over 2 to the first, which is 1/2, which is 0.5. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. So it makes sense. Look at the graph. They went -2 up 0.25, -1 up 1/2, over 0 up 1, over 1 up 2, over 2 up 4. So now you guys can see where those points came from, and look at the shape. Starts out small and grows upward exponentially. Questions on that? Okay, let's do decay. Decay is a decimal between 0 and 1. Bases are never negative. A negative is a reflection, so just keep that in mind. So it's a fraction between 0 and 1, so 1/2 would be decay. Let's plug in -2, -1, 0, 1, and 2. Watch, this would be 1/2 to the -2. I'm only going to show my work on this one time. Remember, what's technically happening is we have a 1 to the -2 divided by 2 to the -2. Don't both of these need to get raised to the -2, everyone? Yeah. Negative exponents are calculated by flipping them and making them positive. So do you guys see why I'm getting 4? Yeah. Okay. So then when we plug in 1/2 to the -1, you could just do it in your calculator. As long as you use parentheses, it'll give you 2. 1/2 to the 0 is 1. 1/2 to the 1 is 0.5. Since we're graphing, we can use decimals. 1/2 to the second is 0.25. So we're at -2 up 4, -1 up 2, over 0 up 1, over 1 up 1/2, over 2 up 1/4. And you can see that's what created this green graph is exponential decay. So notice both of them have horizontal asymptotes at 0. Horizontal asymptotes can get crossed in some instances, but for exponential functions, horizontal asymptotes are never crossed. We'll never actually, reach 0. When we plugged in 0, didn't we get 1? And then when we plugged in negative numbers, didn't we just get decimals? Do you guys see what I'm saying? So we'll never cross the horizontal asymptote, so make sure you keep that in mind. So if you look at this, what's the domain and range of these? Well, isn't the domain going left and right forever? And then the range is, well, if the horizontal asymptote's at 0 and it doesn't cross, you'll say 0 with a parenthesis to infinity. Yes.
What if you were to plug in 0 for y? Like on that graph, what would the x number be?
So 0 equals 2 to the x?
That's it?
No, I'm just asking, is that what you're asking? Yeah. Then we would log base 2 both sides, log base 2 both sides, and then it would say error. Log calculation of some number is just a number, right? You cannot plug 0 into a log. It's an error, so that wouldn't happen. So valid question. Okay, alrighty. So let's go graph a shifted exponential. Now think back with me, if you don't mind, real quick. Look at these green and red graphs. If I shift it left and right, is the asymptote getting changed? No, the graph will change, but the asymptote won't. And the domain wouldn't change, no matter if we shift left and right. But once I start shifting this up and down, won't the asymptote go with it? Yeah. So if I say up 7, you'd have a horizontal asymptote at 7. So yeah, shifts up and down, change horizontal asymptotes. So let's go ahead and graph a shifted exponential. This is the process. Take off the shifts and write down the parent function. Isn't it 2 to the x? Yeah. Make an xy chart. So plug in -2, -1, 0, 1, and 2. 2 to the -2 is 0.25. 2 to the -1 is 0.5. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. You can just do a lot of that in your calculator because you're allowed to use decimals. Is everyone good? I did that quick, but you guys get that you could just type it in your calculator. Okay, now state the shifts in words. That's why we got so good at shifts in 1010, so that like this moment would be easy.
Down 3.
Left 1. So won't we take our x's and minus 1 off of them? Yeah?
Yeah.
And then you said down 3. So we'll take our y's and minus 3. Okay, now before we do that, I want to say to you, okay, so if we normally had a horizontal asymptote like this at y equals 0, you said left 1, that doesn't change it, but down 3, wouldn't that now be at y equals negative 3?
Yeah.
So let's go graph that right now. Our new horizontal asymptote, a lot of times they ask on the test, what's the new horizontal asymptote? You'll say it's at down 3, negative 3. That is going to always be true. No matter what shifts happen on an exponential, it's the shift up and down that gives you your new horizontal asymptote. So if you can remember that, that makes your life easier. So go to your x's and minus 1 off of them. Let's focus on doing that right now. So that would be, whoa, yeah, that's what I'm doing. So that would be negative 3, negative 2. For a minute, I was like, did I make an error? Negative 1, 0, and 1. Let's then go minus 3 from our y's. So that'd be negative 2.75, I believe. Negative 2.5, negative 2. Is that negative 1 and 1? So we know something went wrong if we graph this and it's not creating an exponential shape and it's not approaching the asymptote. So let's graph it in pink. So negative 3 down 1, 2.75. Yep, that's close to the asymptote. Negative 2 down 2.5. Negative 1 down 2 over 0 down 1 over 1 up 1. So if you look at the pink dots, you've got to make sure to actually graph it correctly. It's looking good, but make sure you don't draw it linearly. We know what's happening. It's actually shooting upwards. Since it's exponential and it's coming down to the asymptote, do not cross the asymptote. That's why it's so important we draw the asymptote first, because if you cross it, that is like the most like fundamental thing of an exponential function is it has a horizontal asymptote that isn't crossed. So they say on usually the instructions of how for me to give you points on a test, and usually it says if they cross the horizontal asymptote, just automatically dock them 50% of that problem. So you gotta be careful. Domain is negative infinity to infinity, and isn't the range now negative 3 to infinity? Okay, make sure you use a parenthesis because this is a horizontal asymptote that is not including and is not crossed. So, okay, so let's do another one. I guess if there's questions on that, you got to ask them now because now we're just going to do one more, a little more hard. Okay, moving on. We would start with the parent function. This is the process. You'd say it's exponential decay because of base a third. So you're going to go base a third to the x. You take off all the shifts. You make an xy chart for the parent function. So negative 2, negative 1, 0, 1, and 2. 1/3 to the negative 2 is 9. 1/3 to the negative 1 is 3. 1/3 to the 0 is 1. 1/3 to the first is 0.3. 1/3 to the second is 0.1. I just used my calculator to do that. I really did. I just memorized it from last period. Yeah, okay. I'm a calculator, guys. No, I'm not that cool. Remember, this is considered two transformations. It's a stretch of 2, a vertical stretch of 2, and a reflection over the x-axis. But luckily, they didn't say state the transformations. They said graph. So I'm not going to worry about it. I've memorized from 1010, doing this a million times. We take our y values and we times it by a every time. So we're going to times our y's by negative 2. Do you guys agree? Times by negative 2. Imagine if you had skipped 1010 and then you just had to remember that, you know? Like, that's a lot harder. It's a good thing we took 1010. Right 2. So isn't that add 2, everyone, to our x's? And then we know this one is up 4. Isn't that my new horizontal asymptote as well? Okay, let's go draw in. Up 4 means we're going to add 4 to our y's. And before we graph, we need to go draw in our horizontal asymptote at 4. And now these points will naturally unfold for us as long as we've written down the transformations correctly. There are still a few people out there that are getting them backwards, but most people are getting it right. So nail it down, guys, because you don't want to miss these ones. So let's focus on x's. We're going to have a 0, then a 1, then a 2, then a 3, then a 4. That would be 9 times negative 2 is negative 18, plus 4 is negative 14, negative 6 plus 4 is negative 2, negative 2 plus 4 is 2. Need my calculator for that. 0.3 times negative 2 plus 4 is 3.4. 0.1 times negative 2 plus 4 is 3.8. Graph the points and say, is this looking right? Over 0, down 14. Down here, over 1, down 2. Over 2, up 2. Over 3, up 1, 2, 3.4. And over 4, up 3.8. If you look at the black dots, looks good. It looks exponential in shape. It just was reflected. So now the domain is still negative infinity to infinity, but the range has changed. It went to negative infinity now because it got reflected over the x-axis. So our range is negative infinity up to the horizontal asymptote 4. So from our 10-10 knowledge, that should be overall pretty easy. You guys feel okay out there?
Yes.
Okay. Now what if they ask you to solve an exponential function? Exponential functions can be solved using logarithms, but there are a few that you don't need a logarithm, and trust me, if you don't need a log, you would rather not. It's more likely you'll get it right if you do it by the way I'm going to teach you today. It just doesn't always work. So we're going to learn how to solve some basic exponential functions by the one-to-one property, and they will have some on the test that can be solved like this. They mix them in, though, with the ones that can be solved by logarithm, so kids will forget to solve it like this, and it's just more accurate. It's just easier to not make errors. So here's what you do. You're trying to figure out what is the power of x that will give us 1/27th. We're not going to guess and check because it's not always going to be so obvious. So here's what you do. You're going to write both sides as the same base if possible. How do we know? Well, we don't. So go off to the side and say, let's break down 9 into its completely factored form. Isn't 9 3 times 3? And then let's break down 27. I know it's 1/27. It was flipped over a fraction, but let's just ignore the fraction for now. Isn't 27 9 times 3, which is 3 times 3 times 3? So notice 9 is 3 squared and 27 is 3 cubed. Do you guys see how it's the same base? Then you can solve by what's called the one-to-one property. If you write both sides as the exact same base, you can just solve using the exponents. So let's rewrite this. 9 is 3 squared, so we have 3 squared raised to the x power. Isn't that just 9 raised to the x, everyone? It's more strategic. Now, because there's a fraction, what do we have to do with our exponent here?
Flip it.
Make it negative. You're right. 3 to the negative 3. Do you guys see how that's 1/27? Negative exponent is, oh, it was flipped over a fraction, flip it back up. Are we all good out there? From there, you'd say, okay, let's simplify before we do anything. If you have a power raised to an additional power, you multiply the powers. So this is what we're actually dealing with. And now that there's 1 base 3 on the left and 1 base 3 on the right, it only works if there's 1 base 3 on each side, and there is, then we can just ignore the base and solve using the exponent.
So it's 2x plus, oh wait, no.
So then we'll divide by 2. So x is negative 3/2. You guys see how we just solved using the exponent? Really easy. You definitely want to use that if possible. So look at this one. This would be 2 is just 2. So 2 to the 3x, but isn't 16 4 times 4, which is 2 times 2 times 2 times 2? So 2 to the 4th. So you have this. 2 to the 3x equals 2 to the 4th raised to the 1 minus x. So then you would say 2 to the 3x equals, raise a power to a power and you multiply. Make sure you distribute the 4. So that'd be 4 minus 4x. And now that it's base 2, you can ignore the base. Ding, ding. And then you would just solve your exponent. Do you know how many people will get there and be like, I don't know how to solve that? It's a linear equation. You're going to add 4x. 7x equals 4. Divide by 7. X is 4/7. Okay. Do you know how many of you on the test did this? In fact, oh dear, bless our souls. Cutter Vance.
Oh my goodness.
Are you allowed to reveal that?
I didn't say it was him. He was itching his nose and I was like, stop doing that. All right.
So she definitely.
All right. Some people, Cutter, on the test got this far and then said, I don't know how to solve.
Oh, God.
Oh my
Oh, that was the one you said.
No, a lot of us did. They're like, I don't know how to solve this. I'm like, what do you mean you don't know how to solve this? What do you mean? I've made such a big deal about this and dramatized this so that we wouldn't do this. We subtract 7. I wrote on some of your tests, you're telling me you don't know how to solve a quadratic? And then you factor a quadratic formula. And it was factorable on the test, so it was an easy one.
I just
Crickets. I'm not trying to be mean. I'm trying to help you because you got to be able to solve a quadratic to do okay on our final coming up in the next few months. Okay. All right. Do you guys feel like you need another example with the one-to-one property, or can we move on? Let's move on to logarithms. So listen to a logarithm. How do we graph a log? Well, we create an XY chart. Listen so you're not confused. The problem is, if you start plugging stuff into a log, it's very confusing and hard, and then you have to use the change of base formula to calculate your y values, and you're going to accidentally pick really ugly things. So you're not going to do it that way. So here's what we recommend. Instead of calculating a log, calculate its inverse. Why? Because the inverse of a log is an exponential, and exponentials are easy. So what is the inverse of log base 2, everyone? Nope, but I like that you're trying. Say it over here. It'll forever be in the video. You can always go back. Now you'll have like leverage when you try to sue me. All right, isn't it 2 to the x, everyone? Okay. But I'll have leverage too, because then when you're saying, I was crying and traumatized, you'll see that you weren't in the video. Okay. So let's plug in -2, -1, 0, 1, and 2. 2 to the -2 is 0.25, 2 to the -1 is 0.5, 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. Do you guys understand? That's just way easy to calculate, so that's why I chose to do that. But I can't graph those. Those are the inverse of what I'm trying to graph. So we know how inverses work. We switch our xy points. So log base 2's values will be the inverse of that. So 0.25 -2, 0.5 -1, 1, 0, 2, 1, 4, 2. Now here's what I want you to think about. Isn't it true that exponential functions have horizontal asymptotes at y equals 0? Yeah? See, right here?
Yeah.
Exponentials have horizontal asymptotes at y equals 0. That means if you're switching x and y, logs have vertical asymptotes at x equals 0. So our first thing we draw in is a vertical asymptote at x equals 0. And then our points should approach it and not cross it. So over 0.25 down 2, over 0.5 down 1, over 1 up 0, over 2 up 1, over 4 up 2. And if you look at the purple points, it is exponential, it's just on its side. Remember when people ask me, what is a log? And I made a big deal about it in 1010, I say it's an exponential function, it's just flipped on its side. So a log is just an exponential function flipped on its side. So make sure you graph it growing exponentially to the right and coming to the asymptote. Now, the growth factor just was the base 2 part, log base 2. It doesn't matter what this base is, it just is going to tell you how fast it grows. So look, what if I had a different base, like a base 3, a base 5? It will look the same, it'll just grow different fastness levels, but isn't it true that the domain and range is the same either way? The shape is the same either way. Do you guys see what I'm saying?
Yeah.
Okay. So let's look at a log decay one. So you would start with, I'm going to do base 1/2 raised to the x, make an xy chart. -2, -1, 0, 1, and 2. So that'd be 4, 2, 1, 0.5, 0.25. If you graph that, you're graphing the exponential, so we need to switch it. We just did one like this. I just wanted to show you what a decay log looks like. So 4, -2, 2, -1, 1, 0, 0.5, 1, 0.25, 2. Did I mess that up, or did I switch those? Sometimes I'll like not switch them.
Yeah, no, that's good.
So our vertical asymptote for all logarithms starts at 0. For all parent functions, we are going to shift it. And then notice we're going to go over 4, we're doing red. Over 4 down 2, over 4 down 2, over 2 down 1, over 1 up 0, over 0.5 up 1, over 0.25 up 2. So you can see it looks like this. So notice the domain is 0 to infinity for all parent functions of a log, and the range is negative infinity to infinity. And I do want to point out, because last period, I think if I would have pointed this out, it would have helped people. And I should have drawn these more accurate, the pink and blue. Let me erase this and draw it a little better. Because all parent functions will actually cross through this point. See this point? I'll do it in green. 1, 0. See how it crossed through 1, 0, everyone? All parent functions go through that point. So that point can't be useful in determining, like, what is the growth factor, because all logs go through that point. So just keep that in mind. In the future, that'll be helpful. But, so just recognizing that point is common. Okay. All right, let's do a shifted log now. Should we just do you want to just do one example and let's do the hard one?
Yeah.
Okay, so if you look at this, you would say this is a very long process. To graph this shifted log, this is the process. It just takes an extra step than the exponential. You're going to say, write the parent function of the log. So that would be log base a fifth of x. Once again, you'd say, to create an xy chart for log base a fifth is very difficult. It's hard. So instead, we're going to choose to do its inverse, because it's not hard. So base a fifth to the x is the inverse of log base a fifth. We're not doing an inverse of the big full thing. We're just doing the inverse of the parent function. Plug in -2, -1, 0, 1, and 2. If we plug in -2, we get 25. Plug in -1, we get 5. Plug in 0, we get 1. Plug in 1, we get 0.2. 1 divided by 5 raised to the 2 is 0.04.
That was a good guess.
Yeah, it was a good guess. Okay, so now from here, everyone, you would make sure to not shift that. That's a very common error. Kids will then use that to shift, but then you'd be shifting an exponential function. So make sure you switch. 25 -2, 5 -1, 1 0, 0.21, 0.042. And then I recommend crossing it out so you're not tempted to use it. And now we just perform the shifts. Okay, I'm just writing this down. Currently, our vertical asymptote of our parent function is at x equals 0. What is the new vertical asymptote at?
2. Wait, -3.
No, -3 because it's on the
It's a
x
3.
now.
Correct.
Oh, yeah.
So remember for exponentials, it was the shift up and down. For a log, it's the shift left and right. Because remember how we're switching x and y, everyone? So I should have pointed that out a minute ago, and I didn't. So let me show you back to our parent function of our log. See, look, if you shift up and down, that won't change the log's asymptote, but a shift left and right would. See, if I shift right, left, 5, that would. Okay, so just keep that in mind. So right here, we would say this is a stretch of 4 and a reflection over the x-axis. It goes to our y values. This doesn't change the asymptote for logs or exponentials. Then we're going to say right 3. For a log, the shift left and right is your new asymptote at x equals 3. See, it's really important that you keep them straight. Shifts up and down, go with exponentials. Shifts left and right, go with logs for shifting of your asymptote. Okay, and then right 3. So we're going to add 3 to these. This is kind of a nasty problem. And then up 2. So then we're going to add 2. So writing down my official points, that's 25. Let's look at the x's. 25 plus 3 is 28. 5 plus 3 is 8. 1 plus 3 is 4. That would be 3.2, and that would be 3.04. My y's is that 8 plus 2 is 10. 4 plus 2 is 6. 0 plus 2 is 2. Negative 4 plus 2 is negative 2. Negative 8 plus 2 is negative 6. So go over 28 up 10. Obviously that is off the graph, so I'm going to skip it. Over 8 up 6. 1, 2, 3. Graphed that one. Over 4 up 2. Over 3.2. Over 1, 2, 3.2 down 2, which is by the asymptote. I have enough points to graph this because it's exponential on its side. So would you agree? Look at the 3 purples. You got to be able to draw accurately if you're going to do little points. And we need it to shoot to the right. Do you guys see what I'm saying? You memorize that that's the shape, and then it comes down to the asymptote. So what's the domain it looks like now? Is from 3 to infinity, and our range is negative infinity to infinity for all logs. Okay? Good stuff.
Great stuff.
All right. All right, so now read the problem. It says, this does not say find the inverse. If it did, we would kind of go about this differently. It's the same idea, but we would do an extra step. This just says simply switch these to a log. That's it. Switch these to the form of a log. So you would identify which one's the base. The base is anything without an exponent of 1. So y can't be the base because it has an exponent of 1. So this must be the base. Do you guys agree?
Yeah.
So to undo base 2, we apply a log base 2 to both sides. Remember the algebra of logs. Watch. When you apply a log base 2 to both sides, it's not a multiplication problem. Remember, that's a common error of kids' first time seeing logs. When you take a log, there's no such thing as a log without a parentheses of something. So when you take a log, it's actually log base 2 of y. And on the right, it's log base 2 of base 2 to the x. Do you guys see what I'm saying? Recall that. When you take a log, that stuff goes in the parentheses of the log. So on the left, nothing happens. It's just log base 2 of y. But on the right, if you have log base 2 of base 2 plugged into the log base 2, they're inverses and they cancel out. So that was just a new inverse we learned in 1010, which really it wasn't new to us. We had learned it in Sec 3. Anyways, x is no longer an exponent. X just drops down. Just like a square root undoes a square in a way. I had somebody last period say, shouldn't we have switched x and y? Yes, if they said find the inverse. Isn't that what we do first? But they just said switch this to a log. We're not switching anything. Okay, same thing here. They said switch this to a log. So undo base a third with log base a third. So we know that this is really log base a third of y. Then on the right, I'm going to be lazy. This is log base a third of a base third plugged into it, so it cancels out, so we get x, and we're done. So on the test, it seems like every year they do some more like the next two. So right here it says, rewrite this as a logarithm. Are you going to call 16 or 2 the base? 2, because 16 has an exponent of 1, and we can't do logs with ones. Anyways, so we're going to say, we'll call base 2 our base. So we're going to log base 2 both sides.
So it's log base 2, 16.
Log base 2 of 16 equals 4, and you're done. Don't do it. I mean, like I said, it just says write it as a log.
So is that what you would want us to write, or just log base?
No, yes, that's what they want you to write.
What are
But
the,
on the first two we did, would you want us to write log base 2 of y equals x, or just log base 2 of y?
Equals x, because you're just switching it to a new statement. Same thing here. This is a statement. They want you to write that as a log statement. So what would we undo?
Log base D.
Yeah, why didn't you pick C? Because C has an exponent of 1. So log base D both sides. On the left, it cancels out. So E is no longer an exponent. So then we have log base D of C, like that.
just go with-
Yes.
is log base 0 1?
There's no such thing as log base
Which
0.
one is like log something equals 1? Or
It's
equals
log any base. If you plug in 1, calculates to be 0. All right. So right here says write these in exponential form. It didn't say find the inverse. It said write it in exponential form. So this should be your thought process. If I have to write this in exponential form, I need to get rid of the log. Listen though, because what if it's not this easy? You cannot undo log base 3 if log base 3 has anything added, multiplied, or divided to it. But it's not. Look, it's just log base 3. So we're going to base 3 both sides. 3 to the y. Do you guys understand that that's base 3 to the y power? Yeah? Equals base 3. If it's raised to an exponent of log base 3 cancels out, and we get x is no longer trapped inside the log then. So we've written it as an exponential. The instructions just said write this in its exponential form. That's it. So what about this one? How do you undo log base a fifth? Base a fifth it. So now we have base 1/5 raised to the y power equals x. Okay, right here, write this as an exponential. We would base p both sides. P to the z equals A. Okay, so don't overcomplicate those. Okay, I'm going to show you 2 ways to calculate a logarithm. You ready? Way number 1 is by calculator. If it says you can't use a calculator, you can. So here's what you have to remember though. To calculate this by calculator, and there's always a kid that tries to come say to me on the test, I had a few kids do this in 1010, they're like, hey, Miss Billman, how do you put a base 3 into your calculator? And I'm like, you can't. We learned how to do that, and that's all I can say. It's a test. So you cannot put anything except if you look on a calculator, there's log and there's ln. Now log is secretly base 10, just by the way, but your calculator can only do log or ln. So what we do is we force this to have this base. That's why it's called change of base, so that we can use our calculator. The change of base formula says you can take this and rewrite it like this or like this. So log base b of a can be written as log of a divided by log of b. Or it can be written as ln of a over ln of b. So here's what you have to remember. Wasn't it the base that went on bottom?
Yeah.
Base goes on bottom. Base goes on bottom. So watch. You would say, I'm going to rewrite this as log of 81 divided by log of 3. See? Base goes on bottom. Or I could have done ln of 81 divided by ln of 3. They calculate the same. So then you would just type into your calculator ln of 81 divided by ln of 3. See, it does all the hard work for you. It's 4. Wouldn't you agree that's pretty easy, but you do have to remember it?
Yeah.
Now, if you want to not use your calculator, then you can do it like this, but it's annoying. I just use my calculator. You could go like this. What if it's log base 3? Write 81 as base 3. The question is, can it even be written as base 3? Let's check it out. Isn't 81 9 times 9? Yeah. Which is 3 times 3 times 3 times 3? Yeah. So that would be log base 3 of 3 to the 4th. So then what happens if you have log base 3 of base 3? They cancel out and we get 4. See? We get 4 just a different way. It's like, what do you want to do? Use your calculator or not use your calculator?
Calculator.
Okay.
I'm using the calculator.
So what about this one? You would say, I'm going to use my calculator. So what would you write it as? Log of? 1/25 divided by?
Log 5.
Log 5. Then you'd put it in your calculator and it'd give you -2. What if you were going to do it without the calculator? Then you would have went log base 5 of 5 to the -2. Isn't 25 5, or isn't 1 over 25 5 to the -2? So what would happen with log base 5 of base 5? They'd cancel and we'd get -2. I use my calculator. I just do.
Yeah, I use the calculator.
So this would be log, let's not use log, let's use ln. ln of 4 divided by ln of 8. You guys agree? That's how you'd set it up. 0.67. It's actually 3/2, same thing. Okay, moving on. All right, so solve. Ready? We're solving some basic logs. So you would say x is trapped inside log base 3. So I need to isolate log base 3. Well, isolate means get it alone. Nothing can be added, multiplied, or divided to undo it, but it is alone. So now we would undo log base 3 with an exponential base 3. Are you guys with me? So x equals 3 to the 4th power. Don't be the person that is 3 times 4. Nope, it's 3 to the 4th power, which is 81. So our answer is x is 81.
Got you.
So it's just algebra. Look at this next one. Solve for x. You would isolate log base 2, meaning if there's something multiplied, added, or subtracted, you've got to move it away before you undo the base. But they're keeping it basic. Then wouldn't we base 2 both sides? So base 2 and log base 2 cancel out. We have x minus 1 equals 2 to the 3rd power, which is x minus 1 equals 8. Add 1. X equals 9. Questions on solving these basic logs?
I like the basics.
Yeah. All right, this is the last problem of the day, then I'll let you go work on your homework. It says write the equation of this log or exponential. So you'd ask yourself, is it a log or is it an exponential based on the asymptote?
A log.
It's a log. So we know it's this. Y equals log base something of x, for example. True?
Yeah.
But the question is,
-4.
you're right. You're saying there's a shift of, it was right 4, so that we know this. Log base something, we don't know the base, but you know it's x minus 4.
Yeah.
That's true. Is everyone good there? Now the only question is what's the base? They're not going to do a shift up and down. That's too hard to figure out. So they'll just leave it as a shift left and right if it's a log. And if it's an exponential, they'll leave it as a shift up and down. Do you guys see what they're not going to do
Did you
extra
say
shifts.
If it was up and down, if it was normal, it would go through that first point anyways, right? The parent function would go through that first point on the right side of it.
Like the parent function normally goes through that point. Exactly. So we can tell it's not shifted up and down because it's still, but the question is like, couldn't it still go through that? I don't know. I see what you're saying. So yes, you're right. I think you're making a valid point. If we go right for, there was no shift up and down. Good point. Okay, so here's what you're gonna do to figure out the base. Pick a point that is unique to this graph. So what is a point? If you say 5, 0, that's actually, I mean, maybe that would work. I don't know if it would though, because isn't all parent functions gonna go through that point? Like when it was shifted back to the parent function? So pick a different one. Over 6 up 1. Write it, 6, 1. It's an x, y special point to our log. So let's go plug it in. Y is 1. We have log base we don't know. X is 6 minus 4. So 1 equals log base something of 2. True?
Yeah.
Now from here, wouldn't you agree calculating a log's confusing?
Yeah.
So let's not. Let's
Wait, so
instead,
you can't divide by 2, right? 'Cause it's
let's put an
not-
x there. Can't we just put an x there? Because we don't know what it is.
Oh, it's good.
So now solve for x. Base x both sides?
Yeah.
Okay. So x to the first equals 2. Okay. What to the first power is 2? 2. So 2 equals x. So then you go back and say, okay. So now we know it's y equals log base 2 of x minus 4.
Okay.
So you're going to just first write the parent function with the shift left and right or the shift up and down. If it's an exponential, it'll be a shift up and down. If it's a log, it'll be shift left and right. And then just go pick a point that's kind of unique to it and plug it in. Yeah, if we would have picked 5, 0, you would have been able to catch like, oh, well, any base to the 0 power, you know what I mean, is that. So we can't figure it out with that point. Well, and long story short, we're done. Okay, you're going to go do, isn't this 4.1's homework? Okay, go for it. If you're doing test corrections, make absolutely sure, once again, everyone's taking the test. Remember that your final exam score can replace your lowest test score. So there's a few of you out there that's going to be your saving grace, right? But you don't have wiggle room, so like you cannot slack off on the next 2 tests
Miss Miller,
plus the final.
if I got 3 A's, what's the lowest grade I can get? Ooh, okay.
It has to be a B plus or higher.
Oh, B plus, so we can help that too.
I don't know. I'd have to go look at my notes, so I don't want to be a liar.
It's now, can I tell you right now, 1%, 2% on my test?
You can go put it on my desk.
Yeah,
Wait.
The one from the survey, or not survey, the
Oh,
signatures?
yeah, we can get that out.
Okay. Or like I could just write it on this.
But keep in mind, okay, so wouldn't it be silly, let's say this is a terrible test score, out of character for you, let's pretend, I don't know, I don't remember your test score, pretend that with me.
Yeah.
Then wouldn't it be smarter to not put the bonus on this, because won't your final exam be higher, replacing this score anyway, wasting the 2%?
Oh, so I shouldn't use it until I take the next one, I could get worse on the next one.
Correct.
Does the final exam weighted?
Because then you put it on your better one, right? Because your worst one's getting replaced anyway with the final. You don't put it on your worst, because that's gonna waste it, because it gets replaced with
that
your
makes
final.
sense.
Unless your final is your worst, then it didn't matter.
Okay, that makes
Can I
sense.
put it on mine?
I'll look at it.
It's just, it's hard to say. There's not a date.
Until the end, or probably.
Lincoln,
I just sound like those guys are.
who's gonna win?
I'm not doing it. I have
I have academic study next time.
I've Duke.
Share it, snatch it back and forth, put it in the middle.
Any of the ones you